All right, thank you for joining, everybody. Looks like we've got participants still rolling in, so we'll kind of slow roll this. But thanks again, everyone who's on the call, anyone who hasn't joined, and those who are listening in a later recording. As everyone knows, this is going to be recorded, so if you've registered for this, you can come back and visit this later. Today, we're going to be talking about kind of unified surveying using laser scanners. My name is David Bonney. I work for FARO, channel manager for the AEC segment, which we'll go into in a minute. I'm joined by my colleagues Matt Tepler, channel manager also for AEC and PSA, and he's based in Canada. And then I'm also joined by an end user, someone who's been using the FARO and GeoSLAM technologies for the past 5 years, Mustafa, president and managing director of Infratech Construction. So let's go over the agenda quickly, and then I'll pass this off. So today we're going to cover just a couple things. We'll go through the FARO Reality Capture Toolbox. So we'll go over some of the tools that we offer today. We'll talk about just the geomatics and how we use laser scanning in that field. I'll then go into a little bit more detail about how we use the Orbis scanner and how we use that in the georeferencing field. We'll talk about data collaboration, how we use this data today, but in the in a cloud environment. I'll then pass it off to Mustafa to cover more real-world examples, so using the SLAM devices in the real-world survey world. Then we'll stop. We'll have a panel discussion. Before the recording started, you guys may have seen, but please put questions in that chat. At that time, we'll try to answer as many questions as possible, and any questions that we can't answer today, we'll be sure to get back to you over email. Matt, I'll pass it over to you.
Perfect. Thanks, Dave, and appreciate it. And thank you, everyone, for joining us here. So before we get going, let's just kind of talk about FARO on a whole, just so you guys have a better understanding. So FARO was founded in 1981. Its primary focus is a company that provides 3D measurement and imaging and realization solutions. We have offices around the world. And with primary headquarters in Lake Mary, Florida, we have offices in Stuttgart, Germany, and Singapore, as well as offices around the world. And the great thing about that is it not only allows us to help serve our customers worldwide, but it also helps us make sure that we're providing solutions for specific regional needs of our customers as well, because obviously every country is different. If we break FARO down, we have 3 primary segment focuses. So we kind of break them down into 3D metrology, which would be measuring in fractions of millimeters. So they have typically some more unique hardware solutions. They're used predominantly for things like QC, manufacturing, and other analysis. We have a public safety group that's focused on things like police and fire and related organizations to do things like accident reconstruction, crash analysis, bullet trajectory analysis, and providing visualization tools for presenting in courts of law and things like that. And then lastly, we have our AECO group, so architecture, engineering, construction, and operations, which is truthfully a bit of a catch-all within FARO. But in my experience with surveyors and geomatics professionals, that's where you guys live. You guys get tasked with capturing, measuring, visualizing, basically everything else in the world around you. That's where this kind of category fits in overall. So before we get any further, let's trigger the first poll question if we can there, guys. Keep this a little bit more interactive, and we'll go from there. And while you guys are answering that, I'm going to keep going through some of the solutions that FARO has here. So let's talk about our capture overview and what we have in our toolbox, so to speak. So we have in the AECO market predominantly 2 different scanners. So one being the Focus Premium, which is our flagship terrestrial product. And then the other one is the FARO Orbis, which is our SLAM product. And this is basically as a result of GeoSLAM's acquisition by FARO back in 2022. One little note I just want to point out is if during this conversation and webinar you guys are hearing the words GeoSLAM Horizon, it is basically the last generation that was released by GeoSLAM before the acquisition. It's still a currently sold product. Sometimes we talk about it, and some of the data sets we might be sharing might be from Horizon. So just if you're going, hey, what the heck is that name? I just want to give you guys a clearer understanding of what that is. So if we go from here and look at the product basket from FARO, we kind of have the two different scanners on two different ends of the spectrum. So if we look at this fan here, you can see that we have the terrestrial scanners on one end, generally producing more accurate scans, things like that, but obviously taking longer to do that data collection. And then on the opposite end, we have the Orbis SLAM scanner, which is focused a bit more on speed. Now, FARO's really lucky that we have developed what we call flash scans. Now, flash scans mean a couple different things, whether it's terrestrial or mobile. So if we talk about flash scans on the terrestrial side, it allows us to do rapid data collection. We're talking about terrestrial scans in the sub 30-second mark, which is absolutely amazing. The other big thing is that we have flash scans on our SLAM product, which allows us to create higher resolution, higher accuracy scans, and again, bridge that gap up to more of a terrestrial level. And the big thing for you guys to take out of that is, hey, we have the right tool for the job, and depending on the size and scope and accuracy of the output of what you guys are trying to do from there. And then while all our scans can get processed locally, we do have the ability to interface with our Sphere XG cloud platform. And this allows for increased collaboration and interoperability with various stakeholders of data. We all know that data sharing is turning into a big thing. Dave will talk about this a little bit later. And the other big one I want you guys to understand is that all these technologies are complementary. One tool does not completely replace the other. We all work together to provide you with the greatest flexibility from there. And based on that, if we could just call up the poll results, just so we can have a look at what everybody's responded with. So, to be blunt, this is typically what we see in the market, and at least for me up in Canada, this is what we see exactly. So we tend to have a lot of users of terrestrial. SLAM use is not as much, and a lot of guys are using still the drone lidar, be it various airborne solutions there. So right on board of what we typically see, and absolutely what we've kind of focused this presentation on. So that's fantastic. So. Sorry, guys. So let's talk about the actual hardware itself. And I'm not going to focus too much on the, no pun intended here, of the premium laser scanner. As a lot of people know FARO for our terrestrial laser scanners, we've been producing terrestrial scanners for many years. For those of you guys, based on the poll, who are not using laser scanners at the moment, let's give you the Cliff Notes version of that. The focus laser scanner can shoot up to 2 million points per second. It has multiple range options depending on what your applications are. It has an integrated solid state drive and a removable SD card for easy file transfers and the like. It has wireless on board to allow it to interface with our Stream app. And Stream app, it runs on Android or Apple devices and allows you to control the scanner remotely, allow you to visualize the scan as you go, and allow you to do field registration. And the other big one is obviously it has ruggedized construction, because we all know surveyors tend to be a little rough with their equipment. So we need something that can take a little bit more of the abuse from there. Now, as I mentioned, the other tool we offer that people are a lot less familiar with based on the poll results there is the Orbis mobile scanner using what we call SLAM technology. So let's talk about that for a minute. So the Orbis laser scanner can actually shoot out 640,000 points per second at a range of about 120 meters. It has an onboard SSD and actually has easy file transfer. We can take data off of it either via USB key or via Wi-Fi. That same Wi-Fi allows us to connect to the Stream app, similar to the Focus there, to be able to control, to visualize scans as we collect it. It has the ability to do easy georeferencing, which Dave will talk about as we get a little further in our presentation. There is an integrated camera, so you can see the camera on top there. The camera, right now you're seeing one lens. Actually, there is a second lens collecting a 360 bubble from there. We have local and cloud processing options, and that's a big thing just to stress here. Some people want to send the data up to the cloud, have it processed for them, and almost kind of just be the easy function from there. But a lot of you guys are dealing with clients and end users who are very sensitive of their information. We deal with many government agencies, We deal with the power plants, mines, things like that, that are very limited of where that data can go. So you can absolutely process all this data locally if you need to from there. And the other big one is the extreme flexibility. Now, what I mean by that, as you can see here, this rather happy-looking fellow scanning is holding the scanner much like a spray paint gun. But based on its form factor, we're able to go up and around spaces under, piping racks, around bulkheads, things like that, and really give you the flexibility to use the scanner in a multitude of situations. The other big thing with this is that there are a number of mounts, which Dave will talk about a little bit, allowing you to mount the scanner to a pole to get into other spaces, vehicle mounts, things like that, and really act like a Swiss Army knife in your toolbox there as needed. And I mean, based on you guys are getting requests for all sorts of different jobs from your clients, allow you to potentially bid and work on those jobs for them. So where Orbis sits, I'd like to kind of think of the following with our kind of core value proposition for the unit. So we tend to be focused more on speed, simplicity, and quality. And what I mean by that is speed, obviously speed of data collection. We want you guys to be able to get in, collect the data quite quickly, be able to process the data quickly so you guys can make informed decisions quite easily. We want to focus on simplicity. The scanner is extremely easy to use. Now, my daughter's been scanning since she was 9 years old. So hopefully that's telling that everybody can use the scanner. But what I like to stress with that is it doesn't require a certified surveyor. So you guys can hand it to your junior mine techs. You guys can hand it to your articling students and save your senior surveyors to potentially collect the more intricate, complicated projects and things like that. So allow you to do it. And then lastly, quality, because obviously if the data is rubbish, there's no point doing what we're doing from there. Now, you guys have heard me, already in this presentation mention SLAM, and Dave mentioned it as well. What the heck is SLAM? So SLAM is an acronym for simultaneous localization and mapping. Basically, a real fancy way of saying we're taking laser data measurements in the field as well as IMU positional data, so inertial measurement unit. And we're collecting that data as well as the images and collecting it in the field. And what we do is we bring it back to the office or up to the cloud and process to do 3D feature recognition and essentially do scan-to-scan registration. And the difference being is it's stitching scan from one moment to the next moment to the next moment from there using our SLAM algorithm. And what that does is that gets you a registered 3D point cloud that you guys can use and then take into your various software packages. The big benefit of that is we don't need to remain static while scanning, so you can absolutely move through a space. The stitching is absolutely automatic, and we don't need GPS. So if you guys are going underground or in buildings and things like that, we absolutely don't need any GPS to collect the data. Now, one little point I want to make here is that SLAM algorithm that I mentioned, that is a very important piece. It's the secret sauce of any SLAM system. And truthfully, all SLAM is not created equal. So GeoSLAM, again, that FARO acquired, had been working on SLAM since 2012. So we've been constantly improving and updating the algorithm to work with newer technologies to be the most robust on the market. And that's why we are truly the leader of SLAM technology, in this field from there. So to go from there, what does this really mean for you guys? So let's just look at a speed of capture time just to compare static scanning to mobile scanning. So this is very general here. Obviously, you guys can see this is a pretty complex office building or school or something of the like. So as a very ballpark number, something like this for a data collection would be potentially 125 scans, potentially 5 hours of field capture by the time we get actual scan time, moving the scanner around, getting access to sites, things like that. When you get back to the office, we're probably looking about 4 hours of processing and registration to get you an overall accuracy of about 2 to 5 millimeters. So overall project time for something of this size and scope, let's say potentially around the 9-hour mark. And obviously this will vary depending on scanners and what you're using for hardware. Now, if we were to compare that to a mobile system, so this is what it looks like with a SLAM system. So this blue spaghetti looking line is the trajectory path or where you would walk. And essentially with the SLAM system, you're walking into a room, out of a room, into the next area from there. And the whole building could be captured in potentially, under 30 minutes. we can absolutely generate a point cloud directly from that in a couple of hours. That gets you a raw point cloud. If we want to colorize or do the pictures with it, it's going to take a little bit longer, just as anyone who's done photogrammetry with drones knows that the image processing does take a little bit of time. And the accuracy would be probably dropped down to about the 1 to 3 centimeter mark. So you're trading off a little bit of accuracy for a tremendous increase in efficiency and dropping the time and maximizing that. And obviously, in the geomatics world, everybody wants the millimeters, they want the accuracy, but there's also the big debate is, are your clients willing to pay the money to necessarily get that accuracy? And if they have options to say, hey, we can do this for a little bit cheaper, but go, would this be sufficient? More often than not, that they do take advantage of that. Just want to talk about Flash for a quick second, because obviously I brought it up at the beginning there. Flash is a unique ability within this Orbis scanner, and it's installed in every scanner we do. And what it does is essentially, while you're walking through a space, you can essentially stop for 15 seconds, trigger a flash scan through the app, and basically allows you to collect a specific area with increased detail. So be it a power panel, a valve flange, things like that. But basically, it creates a mini scan within the overall scan. So it processes automatically within the processing software. But the best way to think of it is you have these individual higher resolution scans essentially hung on the overall SLAM scan, like the SLAM scan is a skeleton. And it allows you to merge and bridge that gap between terrestrial scanning and SLAM scanning, which is just a real awesome capability at the end of the day. So just to talk about real world data, this would be a data set collected with just SLAM in this case. This is a hockey stadium in Chicago. The roof has been cut off for this image, so I know it does look like a football stadium. But something like this with SLAM, we can collect easily in half a day. Something like this with terrestrial scanner would likely be a multi-day project. So kind of give you the size and scope of what we're able to do. From there, what does Flash get you? This would be an example of a Flash scan. So if anyone has looked at SLAM data before, typically, the detail on the colorization isn't as high. Flash scan allows us to do this, and this is I believe a bar in Chattanooga near one of where our techs are working, but with great detail on the brickwork and the rock work, but show you the level of detail that we can get out of a Flash scan, which is awesome. But then again, extending that concept of the Swiss Army knife that I mentioned earlier, we can take big scans, cover with SLAM, but then conversely, we can actually take individual flash scans as well and merge the two together, and basically maximizing, again, your ROI and making it just an amazing tool in your toolbox. One last thing I want to leave you guys with is you tend to think of scans going in the horizontal. So again, we're walking through an office building or things like that. But realize that we can absolutely go up multiple floors and stitch things together like that. So if you have multi-level office buildings, imagine being able to scan multiple floors in a single scan is an amazing time saver and allows you guys a great deal of flexibility from there. So yeah, go from there. So with that, guys, I'm going to trigger the second poll question just to make sure you guys are interested and keep you guys awake here. And with that, I'm also going to stop sharing and hand it off to Dave so he can kind of take over for the next section. So please take it away, Dave.
Thank you, Matt. I'm going to share my screen. Okay, great. Yeah, so the second poll question is on the screen. Please answer that. And as we've kind of mentioned a few times, please ask some questions in that section so that we can go ahead and answer those towards the end. And again, if you don't feel comfortable, we'll put our contact information at the end. You can send us questions that way. So I'm going to start talking more about the geomatic application, the applications that we are just, kind of discussing for today, right? So when we think laser scanners, we tend to think of traditional use cases, indoor buildings, facility management, assets, that kind of thing. When we talk to our survey customers, however, a light bulb goes off, right? Our customers start thinking of new projects they can win with this technology. Laser scanning opens a lot of doors for our customers, allowing them to compete and win in project areas requiring data to be accurate and reference to local survey. I'll go through some of these examples and talk about how FARO laser scanning is used in survey control and where our customers are taking these scanners today. As Matt indicated in his slide, we offer many different types of solutions. but we mostly discuss how our Orbis solution fits within the geospatial world. We build world-class hardware, but the truth is, what allows us to go anywhere in this technology is the ability and the flexibility, and more importantly, the data agnostic workflows that we've developed. We work with companies around the world, software that you guys are already using today. From data capture in the field, we enable customers to reference their scan data quickly and easily in our desktop or cloud-based software and ingest it in the solutions that are already developing true value to your customers. Laser scanning has been around for more than 60 years in one form or another. And while this technology has taken great leaps over the past 10 years, one thing is true, there's never one tool that can do everything. FARO laser scanners will work best in the field when used in collaboration with traditional survey tools. Just based on the first poll, we saw that 41% of you have not used laser scanners. So I'll just show you some examples of where these are used and some data, and maybe that'll help kind of churn some ideas. But the general idea is using these laser scanners allows for more effective data capture. It can reduce potential safety issues, and we can collect in complex detail and export to both 2D and 3D formats. We're going to go ahead and review the second poll results, if you can cue that. Great. So as expected, a lot of you are in the land survey. This is great. So we'll go over some of these topics today. We have some government as well, some urban planning developments, civil engineering, environmental monitoring, AEC expected, and utilities infrastructure. So great. I'm going to cover some of these examples in some detail, and then I'm going to pass it off to Mustafa, who's going to go in further detail on each of these and how he's using this our scanners in the field with some of the software he's already using. So laser scanning has always been used in a lot of verticals, and mobile SLAM-based scanners like the Orbis even more. In my 5 years working for FARO, I've worked with all the customers that are kind of working in these verticals or these segments on my left. I won't go into each individually, but just so you know that we are definitely in these industries. We don't allow ourselves to pigeonhole the technology only for AEC or O. Rather, we work with partners who are developing solutions that work with our scanners, expanding the possibilities of where they're used. I'll show some data examples again, and then Mustafa will go into those details. The FARO Orbis scanner was the brainchild of, as Matt mentioned, the acquisition of GeoSLAM in 2022, and the great minds at FARO who bring what Matt has referred to as a Swiss Army laser scanner to market. While Orbis is a class-leading SLAM device on the market today, real-world coordinates need to be post-processed in the data for it to be georeferenced. I'll go through how our customers are using Orbis scanner to register and export to local survey, increasing the accuracy and providing millions of georeference data points in just a few easy steps. The most commonly used workflow to georeference Orbis data is known as stop and go, previously called adjust to control. This is the process of stopping while scanning over a survey, and then being able to mesh those two data points in our software, which is an automatic feature. Surveyors generally use different techniques for capturing accurate geospatial information. And that information is marked throughout the physical scene to help the laser scanner adhere to it. Survey control, checkerboard targets, reflective targets, spheres, and locate are all tools that we talk about when we think of Orbis and georeferencing. And locate there is a FARO method and FARO terminology that's using a GNS receiver along with the laser scanner. You use a backpack or other method to adhere the receiver to the scanner, collect data as you walk, and then again bringing that into the software to do analysis. And then the graphic to the right just shows you an example of 4 control points, and the blue is the individual spots where we stop with our Orbis scanner. So before you start any survey, or in this case, a scan, we always get a lay of the land, right? You want to know, you want to make sure that your survey control is spread throughout the scene, providing the most accurate final result. Generally, in survey, the more points you have, the more accurate your overall data set's going to be. In this example, we laid out just 4, but this was just a backdrop for what we were scanning, which really was the facade of the building. And by spreading our points evenly throughout kind of the scene, we would increase the accuracy of every single point on that building surface. So I talked about our stop and go workflow. This is just an example of how we can do that, right? So both a vertical or horizontal surface, We will have physical survey points on a ground, or I mentioned a horizontal vertical surface. And in order to capture that, we just push the scanner on top of that and let it know, hey, this point's important. When we bring this back into the software, we can then adhere to survey control. So I've got just a little video here that'll kind of demonstrate how this is done. So I wanted to explain the workflow further. So here's kind of a video. Being a SLAM scanner, we always start in a stationary location. We press start. That gives the scanner an XYZ start location. As shown in the video, that other screen you saw was called our Stream app, which Matt talked about earlier, is both in Apple and Google App Stores. And that just gives you a readout as you're kind of walking the scene and gives you an instant display of what you're doing. When you come up on your survey control, you want to stop and mark that point with either the app, or you can use the scan head and then continue on your way. So here I'll pop back into the app and you'll see where I just kind of mark that survey control. That easy. This also works with our monopod. So the monopod is a 10-foot pole that we include with our Orbis scanner, and this can be used as well with survey control. And the same functionality with capturing that control. The software knows I use the monopod, and then I just give it the value of the length, and then that will adhere the scan data to that exact point. Lastly, I talked about it, but it can be on a vertical surface. This is just a video of me in an office building using a checkerboard target and using the scanner on that surface. I referred to it in the previous slide, but essentially another workflow would be using reflective targets. These are just targets that are laid without the scene, and when the laser hits the surface, it does come back with a different intensity. Our software can then pick that data up and georeference it based on the XYZ point given on each of these targets. So in the two images on the right, you can see these red targets are bright and shiny. What that will do is triangulate those within the scene, add the XYZ point, and survey your data in. Lastly, spheres and checkerboard targets. These tools are very much used in all different types of laser surveying. So this could be registering of terrestrial data, but it can also be used for survey information. So we can then survey in each of these targets, and when we bring it into the software, again, the software will do this automatically, and it'll triangulate and georeference your data set. I'm going to quickly go through some geomatic examples so that we can deep dive into some of these more real-world examples. Survey is time-consuming. It can be dangerous. Laser scanning in collaboration with survey is a great workflow to decrease the time in the field and increase the overall data quality and accuracy. We'll go into this in a little bit more detail, but some of the screenshots I share here are real-world examples from our customers. The example here on the right was done by a colleague in Europe. When he approached a scan of a large city, he was able to attach it to a bike and capture a large area in a short period of time. The data was proved invaluable. It was collected in less than 30 minutes. The end customer was then able to add in survey control, which allowed data to be more importantly added in with geospatial information and used in geospatial applications. Another example that's not quite often thought of with a mobile scanner, but bridge analysis. Bridge and large structure capture can be difficult, whether it's on land or in water. So a laser scanner provides millions and millions of points of areas that are otherwise very difficult to adhere. So when you're pre-planning, during an active construction site, or even after completion, the Orbis scanner allows for quick and easy deployment of that laser scanner. Another example here of more of a difficult environment, right? I'll let this video play for a few seconds, but this is just an example of how robust our SLAM algorithm is. We can bring this tool in environments that other laser scanners might struggle. So we collected this underground corridor with good precision throughout. And then using the surface data that we captured with survey control, we could then georeference the below scan to that above scan. And now we have a georeference scan underground, again, something that is very difficult to do with traditional survey tools. Another example of a downtown area, further exhibiting more of the Orbis capability. Matt talked more about like flash, which is the ability to get into an area this large. This area was captured in 17 minutes. And when the client had areas of high precision and more detailed requirements, we were able to stop and take 15-second flash scans. When we talk about precision, we're talking about 5 to 10 millimeters. That is of a general area, and as Matt talked about, more on the centimeter scale when you're thinking of the larger scale project. When we talk about survey control, we generally talk in millimeters. that's when we can do what's called a non-rigid transformation to bring this data onto survey control. That's transforming the point cloud around that data, increasing the overall accuracy of the scan. Here's an example that some of you probably already work on today, right? Using laser scanning is rarely an end deliverable, but the attributes in the scene are. Reducing the time in the field allows for more time in the office to generate outputs. In this case, classifying the data and marking key components in the scene, whether the scanner prior to the project development or simply documenting the area for records, Orbis is up for the challenge. In a similar vein, our customers can return to the site after completion and add in further documentation efforts. Surveying a single point at a time can be time consuming and of course limiting the overall data in the office. The Orbis scanner is versatile enough to capture an entire scene, register to local control, and provide quick measurements that can be made to make better and more precise decisions. A couple more examples and then I'll pass it off, but a few unique customer use cases with the Orbis scanner. If you've ever tried to set up and deploy a terrestrial laser scanner in a hard to reach area, you know how a handheld tool could be easier. So the Orbis scanner can be inverted by simply flipping the scanner upside down and tethering it to a pole or a cradle for instant data capture and underground features. Similarly, the size of the device allows it to navigate hard to reach areas, right? Whether you're using this as in your hand or putting it on a automated device. Our provided monopod makes it extremely easy to get into tough to reach areas above your head or above a ceiling fan, for example, all without stopping to do any additional setup. We have some customers deploying Orbis on their vehicles, which can make it even quicker to capture. Just a disclaimer here that our devices are not going to be driven on highways and byways, right? This is something that you're going to be driving at less than 15 miles an hour. So think of side roads, think of small bridge areas, think of neighborhoods, airports, very common use case for this technology. And in this case, you would use checkerboard targets or other geospatial target information to geo-reference that data back to your scene. Corridor surveys for capturing, utilities and linear infrastructure such as road, railways, variety of applications for inspection. The Orbis scanner makes it easy to go back to a site weekly, daily, monthly, whatever it may be, for change detection analysis, or large railways and large areas that might be harder to do with any other tool on the market. Just a reminder that you can deploy, as Matt described, on different surfaces. So in this case, we have it on a backpack to make it a hands-free environment. Stockpile survey is very important in the survey world, but for volumetric analysis, right? Any bulk materials inside, external ore, grain, wood chips, etc. Very, very easily captured with an Orbis scanner, and volumetrics easily pulled from that information. Forestry applications, another one that's classic for survey, whether you're doing tree counting, tree volume, carbon volume, biomass, forest research, etc. A very quick and easy tool to deploy. And then finally, utilities, right? This is one that we generally use with our locate scanner or just a handheld scanner, but a lot of geospatial customers that need to capture pole location, cable location, pole load, sag, maybe difficult terrain, substation mapping, or impacted areas. Very easy to deploy that scanner. My last slide, I'll talk more about collaboration. So FARO recently announced Sphere XG. XG is our cloud-based collaboration tool, which is easy to access worldwide, right? So pushing the data both for data processing or just data dissemination, right? Getting the data in the hands of your end users or other people on your team. What makes Sphere XG so powerful is it talks directly with our desktop software. So if you make changes to the data on your desktop, it will automatically upload that to Sphere XG, which can be disseminated further to your clients. So at this point, I'll introduce Mustafa, and I will turn my camera off.
Hello, everybody. Thank you for inviting me, and thank you for attending. We are a small firm in Northern Virginia, and we offer surveying and design services. Also, you're active a lot in the construction business. So my name is Mustafa Pokiani. I'm the managing director of this company. There is not much time. I try to convey you as much as information I have. regarding what we do with 3D scanners in combination with conventional survey equipment. We have been using the 3D scanner for quite a few years. I've done about more than 500, just alone in the 3 years I was looking at about 500 scans. So most of them I ran myself, and every time we compare it to the points that we shoot with the conventional surveying equipment. So as you can see on this slide, on the left side, you see the 3D scanner, which is really simple to use. You just hold it literally in your hand, you just walk. You don't do anything else. You're not worried about any height that you need to enter. You don't need to be worried if you are getting the right point or not, if you're looking at the right corner or not. On the right side, you see the robotic total station that we're currently using. And of course, you have a whole setup with that. You have to set it up. You have to get your backside, a lot of other things. But I would like to tell you about the real survey. So this is a survey that we performed about 10 days ago. So this is the real world out there. It is heavily wooded. So we have a lot of projects outdoors. And at the beginning, I was really skeptic if we can get the data that we need. So on the left-hand side picture, you see the general condition of these wooded areas. And on the right side, I'm trying to show you how we do this so far without the 3D scanners. So we set up our instrument in the wooded areas, like here, and there is a prism that has to reflect the laser back to the instrument. And of course, if you really look at this picture, there are leaves around, there are many things around, and you do not have a clear sight. You don't see it. So how it works here? There was a 3-man crew about 10 days ago out there. So one person is, of course, at the instrument. You can have a robotic, you can have another instrument, you can have whatever you have. If you do not have any sight, then there's nothing you can do. You have to cut the line, you have to make a hole. In this case, the instrument man is looking really through the leaves to find a very, very tiny, small hole in order to see the prism and to shoot that one point. That's how we're collecting point by point. And I would say, in an average, we would need for a point, if you're good, about 3 minutes to shoot a point. It's very difficult, and it's very rough terrain out there, and very slow. And not to mention, temperatures over 90 degrees, humidity over 85, everybody is sweating, and after 5 or 6 hours, you're losing your concentration. It's really hard. And on this special project, I would like to show you how many points we were able to gather in about half an acre lot. So versus what we did with the 3D scanner. You can see the blue points. The blue points are the ones that we gathered with our instrument. And the red points are the ones that we created from our 3D scanner. And then, especially on the northern part of this drawing, and on the upper part, you see only a few blue points because it was really tough to get these points. And then now you can see what we created with the 3D scanner. So you cannot compare how much more information you can gather compared to the conventional instruments. And of course, from day one, when we spent all that money, we were concerned, how accurate can we be? How how precise is the whole procedure? Again, you don't see anything. You don't have any influence into this. You're just walking around. That's all you do. Let's go to the next slide. So again, the red points are the ones created from the 3D scanner. The blue points are the ones that we shot with the instrument. So now let's take a look at the numbers. If you look on the upper right-hand side, you see 101.22 versus 101.23, which is really amazing. You know, it's all brush, wooded areas, very dense. On the lower one, 101.11 versus 101.17. And then there's one point on the left side, they're almost on top of each other. 103.97 versus 103.99. Every time we go in with a conventional survey equipment, I'm really happy if I can recreate the same survey within 100, because all the conditions change, everything changes. The temperature changes, the environment changes. Within 100, we're always happy. But look at this, what we were able to gain with the 3D scan, I could not believe it. As I said, precision is really important for us. So these are the points that was really important to show you. Critical surveys. We had some project. So in this case, you see a bridge being built over a highway, over tracks, and over metro, all at the same time. And there is no room for mistakes. You have to be precise. As you can see on the lower part of this drawing, you see the bridge is on the ground and it's being assembled. To the left side of it, the crane is being assembled, getting ready to lift this bridge onto place. Before this happens, there is no room for mistakes. All the operations are ongoing. So the trains are they cannot be shut down for a long time. We had only about 2 hours for the whole setup of this bridge, about 175 feet of span. We went back to make sure that everything is okay, that this bridge is going to fit, and we scanned the bridge itself, and this is one scan that you see all at once. On the upper side, you see a lower intensity because we shot it from far away. And the more intensity, the darker intensity, that means we were closer to our target. Nevertheless, even the points with less intensity, it's so much more information available that we still can work with that. Again, you're taking only one shot for that ground survey. You're taking a shot at every 15 feet, at every 20 feet, because anything else would not be realistic. But with the GeoSlam or with the 3D scanner, you can see really the shape of things that you're dealing with. So that was a very critical one. Again, the same situation on another span. You can see the tracks clearly, and you can see again the crane on the upper right side getting ready for the next span. The span was already assembled. Of course, we cannot just cross the rails or cross these facilities. So in this case, I was away about 67 feet from the farthest point, and I still got a very good image of that, and very, very precise. Let's go to the next scan. This is the same situation. Before the bridge goes up, we need to confirm our clear height. We need to make sure that nothing that everything is as it was designed, and nothing has failed in this case. We see on the left side the piers and the apartments. On the right side, the same thing. Again, less intensity on the right side because I was far away, but still enough data to create this survey to see how the situation is. The blue lines are showing the bridge before going up. So it's pretty accurate, and that's the only way. That was the only way for us really to do this survey, because we had no room and we did not have any permit to set up anywhere near the tracks or close to the tracks. It was not accessible. I was really glad to have the 3D scanner. Let's go to the next one. This is a regular building. We do some of these surveys, topographic surveys, really important for surveyors. House locations and wall checks. So you see the pure scan. So that's what I do most of the time. I show just the pure scan. It's showing you all the detail, and the red dots are the points that we shot with the instrument. Precision is really important for us. So we need to make sure that our wall checks and everything else is really in place. So in this case, I'm zooming in really close to one corner of this building. That's what you see on the right side. We took 2 shots close to each other. And you see, this is pretty much at the middle of this line. It is very close. It cannot be any more precise than that. And even after all these years, that thick line, this is the correct survey, not that 1-point survey, because the reality is that the wall is not straight, it's not 100% straight. If I would get 10, 15, 20 shots vertically on top of each other, I would be in the same location, very close, because the forms are not straight, the walls are not straight. And in this case, I really question myself and even sometimes question my work. Who's right, who's not? Is it the 3D scanner, or is it really 1 or 2 shots that we took at that corner? Let's go to the next slide. We do stormwater computations. So this is a culvert at the outfall we needed to perform and to show that we have our outfall is going to work. These 2 culverts have been in place for the past 50 years, so it was not easy to really get into that area. This took me only 5 minutes, literally only 5 minutes. So versus, we would have mobilized a 3-man crew, a 2-man crew at least, to go there, clean the line, set up the instrument, getting backside through all these dense brush and so on. But this, I just roamed around, I just walked around, and I got the shape that I needed, I got the form that I needed, and I got the length profile and the slope of these culverts for my computation. Let's go to the next slide. Building measurements, we do about 5% of our survey is about inside the building. So this store was fully filled up. There was no way to pull the tape and measure the walls. It was simply not accessible. So I ran through this store only 5 minutes, and I can tell you with I'm very confident that my survey was within ½ an inch plus minus of what it needed to be. Then again, you don't know what's right, what's not, because you don't know if the walls are straight or not. We are measuring the length of the wall only at one corner. I have to speed up a bit. I would love to share you as much as information I can. Let's go to the next slide. Height surveys, height certifications. As you can see, this is the real world. It's showing out there, and we show the height of the building. To really, that's a very realistic survey. Next slide. On this project, for example, we had to show the transitional screening. So we had to show how dense the tree line is, how tall it is. It would have taken us days and days. I performed this scan only within 25 minutes, I was able to return my plans within a day to show the real world out there how it looks like. Next slide. Unintentional surveys, that's my favorite. So we did not intend to do this survey. We were not hired to do this survey. So we did the survey on the neighboring property 2 years before this drawing was created. About 2 years later, I was contacted if we have any information for this lot. They had trouble with the planning because the house was long gone. They demolished the house. Sorry. So the house was demolished. It was all gone. I looked through my scans. So I looked through my scans and I saw I had the entire face of the building. I was able to recreate the existing ground before demolition 2 years before that to do an average grade survey. And as a matter of fact, in the rear area of this lot, I had a very, very low intensity. There were only a few black points. So I went back to those corners that were untouched. As a matter of fact, I hit those points vertically within 0.1 of a foot, which is really great, which is absolutely unbelievable. Next slide. This is the exact same survey. You can see the average ground computation, again, long before the building was gone. Next slide. Oh, that was the last one. I don't know if you have enough time. I would like to share quickly my software screen with you so you can have an idea how it looks like. Again, there's so much information I would love to share with you, but unfortunately, there's not enough time. So this is how the screen looks like when you work on it. This information is all being created automatically. You can create sections, and from these sections you can extract whatever information you would need. This software is a very simple software. I've tried many different softwares. Everything else is very time consuming. You need a lot of resources, but the software I got from the beginning, it's very convenient. You see on the upper right side your coordinates. You can extract whatever you need. One more last thing before I pass it on over to David. One thing that you need to get away from the surveyor's mind. The surveyor's mind is looking for points. And when we bought this unit, we had the training. It had been sitting there for 4 months. We really did not know what to do with it. The problem was not the device. The problem was my imagination, because I was looking for points. And as a matter of fact, you have millions of points, much more than you would gather in the field with a conventional survey. And you need to learn to work with shapes. These are the tendency of a line. It is not the exact point, because you cannot compare your one point that you took in the field with millions of points and with the entire tendency of the terrain, of the building, of the column, or whatever you're surveying. You need to start learning, thinking in shapes. Nevertheless, you can still extract the points that you're looking for, which is really great. I really love that part. Again, thank you very much for attending. And if you have any questions, the time was really short. If you have any questions, any technical questions, you're more than welcome to contact me. I will try to respond to you as much as I can. David, I pass it on to you.
Thank you, Mustafa. Yeah, very, very much. Very interesting stuff there. I appreciate you sharing all that. If you can go ahead and unshare your screen, I will jump back into it. As Mustafa shared, right? So he bought a tool that he wasn't even sure how to use it right in the field. And that's important to understand that both our local distributors and FARO provides training on all these scanners. So when Mustafa purchased this, we went out, we trained him, and it really, how to use the tool is not the hard part. It's how do I get a solution, a derived solution out of this? So I'm going to ask a couple panel discussions. I know we see some people leaving here, and then I'll get to questions. I see we have 3 questions or 4. So just a quick question for you, Mustafa. Compared to traditional survey that you showed today, can you provide an estimated cost that was saved by utilizing the mobile laser scanner?
So it depends on what kind of project you do, but nevertheless, I told you at the beginning, in that wooded areas, we spent a 3-man crew was spending about 4 to 5 hours gathering only a fraction of those points that we could get out of the 3D scanner. It is to a point if our 3D scanner would not be with us in the field, it would be really difficult. It's I don't know how to put it in numbers, but there are
yeah.
Absolutely. But then what I forgot to tell you, that scan that I did in the wooded areas, it took me only 15 minutes. 15 minutes, I got all of that versus a 3-man crew, a fraction of that. It is absolutely, I can tell you in some points you might be even easily save 500,000, 1,500, it depends on what kind of project you do daily.
Yeah, and I guess that kind of leads into my next question, which was, how easy was it to adapt this to your existing workflow? And I think you talked about it a little bit, but if you could just expand further on where you took this data to actually do some of your analysis.
Again, after all, I think I should have thought differently from the beginning. It was just my surveyor's mind, looking for points. It made things so much easier. You cannot imagine that. For example, trees, we would shoot each tree one by one. We don't do this anymore. Canopies, we don't do this anymore. Buildings, most of the corners of the buildings that you do not see, we do not change our position. We do not change our setup. We just rely solely on our 3D scanner. It's very easy. I mean, once you 1 day of training or 2 days of training, I can assure you, you're good to go.
All right, one last question, and this is a softball, but could you replace all your traditional survey equipment with a laser scanner?
It depends on what kind of accuracy it would give me. Gotcha. Honestly, if you would tell me within 1/10 of a foot, I performed today after all these scans, I would be confident enough to perform that scan, to prepare my entire topographic survey. But again, within the accuracy of plus minus 1/10 of a foot. But generally, you cannot solely rely on that because you still have to establish your control points. If you are doing a survey that it's really that should be very accurate, or is an absolute coordinates, you still have to establish those. But we spend only now an hour to set up our general setup for a regular topographic survey, and we can scan it within 15 minutes. I do 2 scans just in case something goes wrong. I try to get all of the corners. You cannot replace it 100%, but I can tell you we already replaced it with at least 60% of our capacity.
That's excellent. Thank you for sharing. Since we're up against time here, I do see that's 2. So let me go ahead and ask some questions that we're drawing in here. Matt, I'll ask you the first one. Could scanning be an alternative method to existing AutoCAD files of a venue? And the example given is a hospital for BIM 3D of a whole hospital. We have cases where AutoCAD file plans aren't available.
I don't think it would be a complete replacement. It obviously is a supplementary tool to do a snapshot, but obviously a point cloud is not a model, and that's the matter of contention. There is it won't do it all, but it will get you a good chunk of the way there. And Dave, would you I guess agree with that kind of statement?
Yeah, so just a comment there. Of course, Mustafa was showing you a lot of scans from the outside of a building, but yes, these scanners are absolutely used for internal, in this case, a hospital. We've scanned quite a bit of hospitals. Just keep in mind that all laser scanners have their use cases, and a mobile laser scanner is going to be a little less dense than if you use a terrestrial laser scanner. So to answer your question, a Orbis scanner, for example, which will get you LOD 250 to 300, whereas you need fine detail in the piping and things like that, you really do need a terrestrial laser scanner with a lot more density if you're going to be doing very fine detail. Second question, how long would it take and what tools and scanning mission are recommended for a hospital with several wards and building in the same venue for BIM 3D data acquisition? Matt, you want to take that one again?
Yeah, I mean, I'm just thinking, so guys, we do have a data set that we can actually share if someone wants to see it, of a project we did in London, scanning the whole hospital in less than a day. So from a mission perspective, you would be, again, depending on the level of detail, as Dave's saying, again, if you were trying to model, electrical conduit, then you're going to be using a terrestrial. If it's just more, hey, where's the wall spaces, windows, openings, as-built type situations, you can easily scan that in under a day, and we have. And a typical mission on something like that would be, obviously pre-planning a little bit just to know where you have access, things like that. You would get on site and essentially walk potentially, let's say, a floor and a half, and then do the next floor so that you have some commonality to potentially merge multiple floors together and go from there. And that's how I would recommend doing something of that size in that scope. Conversely, you can also do it in instead of floor-based. Quite often, a lot of our clients will do it in sections. So this ward would be one section, this would be another, and then eventually potentially merge it together, be it within FARO software or within a CAD environment.
Excellent. And then last question, can this be used in field documentation of utility pipe installation, possibility of locating features, specific connection, points of interest, etc., all this to create as-built drawings? So yes, absolutely. So keep in mind, laser scanning, as I just mentioned, have different levels of detail that you're going to get with the scanner. With an Orbis scanner, you're going to be able to do 2-inch pipe or larger, or more importantly, document the overall area that you're going to capture, right? If you're doing a prefab situation, you're almost always going to use a terrestrial laser scanner that has a millimeter or two of accuracy, right? Because where those connections happen, even if you have a millimeter off from your plan, that could be a big problem. So keep in mind that all laser scanners are built differently. The Orbis laser scanner is definitely more for larger areas. With the flash capability, you can get some pipes. I think we can map, or model about 2 and 3 inches.
Yeah, and Dave,
any other questions before we jump off? Oh, go ahead.
Oh, and to just supplement that, and that's where that flash would come in, because obviously a lot of the piping, if it's long straight runs, obviously very easy. When you hit a junction point, you would do a flash scan to build up the data in that section, and then keep going through, and the two would be merged in the same data set, which would be extremely handy. So
fantastic. Yeah. Well, that does complete today's webinar. I'm looking through questions. If anyone else has any last minute ones, I've also put our contact information on the screen. So please reach out to us individually. You can reach out to the hosts, and we'd be happy to follow up with you. Thanks again. I appreciate Mustafa, Matt, both your time today. I thought this went great. And I hope this spurs some additional comments and questions from the participants. We look forward to speaking with you. So thanks, everybody.
Thank you all. Thank you.
Thanks, everyone.